Probability distributions are mathematical models that can be used for probability computations. These models are further used in statistical inference. Usually, mathematical statistics books introduce these concepts starting from the definition of random variables, probability density functions, and their properties. But if your aim is to use probability distributions in statistical inference, many of the mathematical constructs can be avoided. So, in this video, I will be explaining the concepts related to probability distributions using the minimum required mathematics. Generally, probability distributions are classified into two categories: standard probability distributions and sampling probability distributions. We will start from standard probability distributions. Standard probability distributions are probability models used in statistical data analysis. Statisticians have derived several standard probability distributions. Depending upon the nature of the variables that generate the data, we can decide which probability distribution is to be used in a given situation. In this series of video lectures, I am discussing only three standard probability distributions, namely binomial distribution by Jacob-Bernoulli, Poisson distribution by Simon D. Poisson, and normal distribution by Carl Friedrich Gauss. My ultimate aim is to lead you to statistical inference. Hence, there is no scope for a detailed discussion on standard probability distributions. Standard probability distributions are governed by certain parameters, and hence the properties of the distributions can be specified in terms of these parameters. We will be discussing only major properties of the distribution. We will begin with binomial distribution introduced by Jacob-Bernoulli. If the variable by which data is generated can be interpreted as the number of success in a finite number of Bernoulli trials, binomial distribution can be used as a probability model. A Bernoulli trial is an experiment with only two possible outcomes, say success and failure. For binomial distribution, there are two parameters. One, the maximum value of the variable, usually denoted by n, and the second one, probability of success, denoted by p. Thus, a binomial distribution with the parameters n and p is usually denoted by b and p, capital B in a bracket n comma p. There are several situations which can be modeled using binomial distribution. Number of loan defaults out of a total 100 loans sanctioned by a bank. Number of fraudulent transactions in an ATM counter out of 1,000 transactions. Number of defective products from a sample of 50 products. All these situations can be modeled using binomial distribution. Number of loan defaults out of a total 100 loans can be considered as a case of number of success. Number of fraudulent transactions in an ATM counter can be considered as a case of number of success. Similarly, number of defective products from a sample of 50 products can also be considered as number of success. Hence, all these three situations can be modeled using binomial distribution with the respective parameters. Next, we are coming to the properties of binomial distribution. First one, mean of binomial distribution is given by n into p. Second one, population variance sigma square is given by np into 1 minus p. Third one, for large values of n, the distribution is symmetric and mesopartic. Finally, the fourth one is probability associated with binomial distribution is given by the probability function, which is known as probability mass function, given by probability capital X is equal to small x, which can be represented by P of x equal to ncx p raised to x 1 minus p raised to n minus x, where x can take the values 0, 1, 2, 3 up to n. Here, this is the notation for combination ncx. Binomial probabilities can be calculated using these Excel functions. Probability mass function, that is probability x is equal to small x, can be calculated using the Excel function binom.dist x comma n comma p comma 0. Cumulative probability, that is probability x less than or equal to x, probability up to this small x can be calculated using binom.dist x comma n comma p comma 1. There are 4 arguments in this function. First argument is the value of x. Second argument is the first parameter n. Third argument is the second parameter p. And the final argument is a logical value. It is 0 for density function equal to and 1 for cumulative function less than or equal to. Finally, there is a remark. If you need probability x greater than x, it can be taken as 1 minus probability x less than or equal to x. Recall the formula for the computation of complement. Similarly, probability a less than or equal to x less than or equal to b, that is probability from a to b, can be evaluated as probability x less than or equal to b minus probability x less than or equal to a minus 1. Probability up to b minus probability up to a minus 1. Thus, using these two Excel functions, we can calculate all binomial probabilities. Next, we will take an illustrative example. The situation is as follows. A salesperson in a marketing department has to make 30 sales calls per day. From experience, the company knows that in the long run, 2 out of 3 calls are successful. Your first question asked is, specify the distribution that can be used to model the resulting data set. So, what is the variable behind? Number of successful calls out of 30 calls. Number of successful calls out of 30 calls. Clearly, the situation is number of success, so it can be modeled using binomial distribution. When I say binomial distribution, I have to specify 2 parameters, n and p. N is nothing but the maximum value. Here, maximum value is 30. And p is nothing but probability of success. You are given that from experience, the company knows that in the long run, 2 out of 3 calls are successful. Therefore, probability of success p is nothing but 2 divided by 3. Thus, the distribution can be modeled using binomial distribution with the parameter 30 and 2 by 3. Second question is, what is the average number of sales that can be expected from him per day? So here we have to calculate average value. From the properties we know, population average mu is given by n into p. So I can use 30 into 2 by 3, average number is 20. Third one, what is the variance? From the properties we know, variance sigma square is given by np into 1 minus p. That is 30 into 2 by 3 into 1 by 3, which can be calculated as 20 by 3. The next question is, what is the probability that exactly 5 calls are successful? Exactly 5 calls means mass function, probability x is equal to 5. I can use that binom function. Using that binom function, I will get the probability as 0.00000002. I will show how this probability is calculated. So this is the function to be used. I will enter that function here, equal to binom dot dist. X is 5, n is 30, p is 2 by 3. Since it is then mass function my logical value must be 0. You will get it as equal to this probability. Next question is, what is the probability that at most 8 calls are successful? At most 8 call means maximum 8 calls. That is less than or equal to 8. Probability x less than or equal to 8. Again, you can use that binomial function to get this probability. So here I'll be using again binom dot dist in a bracket. Here x value is 8, n value is 30, p value is 2 by 3. Here we have to find out cumulative probability. Hence, the logical value must be 1. You can enter. You will get probability like this. Finally, the question is, what is the probability that at least 7 calls are successful? At least 7 call means greater than or equal to 7 calls. Greater than or equal to 7 call means 1 minus probability x less than or equal to x. Now, you can calculate this probability x less than or equal to x using the binomial function and take 1 minus. You will get the probability as 0.9999 like that. Next, we have to discuss Poisson distribution and normal distribution. That we will do in the next video. Thank you.